Okay, so as promised, the video for the solution to that example that we started in class. So we have car A following behind car B, and it's 20 meters behind. B is going 22 meters per second, and A is going 20 meters per second. A decides it wants to pass, so he begins to speed up at a rate of 2 meters per second squared till he catches up to B. So the question is, how long does it take to catch up to B, and how far have each traveled? Okay, so we don't know how long it's going to take, but we know that however long it takes, two of them are traveling the same amount of time. And for car A, the equation will be VI delta t plus 1/2 A delta t squared. For car B, its delta D will just be V/av delta t. We have three unknowns, the two delta D's and the time, but we know that delta D's are connected because delta dA, this whole thing, is equal to delta dB plus the 20 meters. Oops. Okay, so delta dA is equal to delta dB plus 20 meters. So now we can take our expression for delta dA and fill it in. So it'll be VI delta t plus 1/2 A delta t squared. And delta dB, we can fill in V/av delta t plus 20 meters. Okay, this time the VI and the VAV aren't going to cancel. It's going to be a quadratic. So let's bring everything over to the same side. So here's going to be my AX squared term plus VI delta t minus VAV delta t. That's going to give me my BX term. Minus 20 meters is equal to 0. If I fill my numbers in, so it'll make it easier for you, so 1/2 2 meters per second squared delta t squared plus 20 meters per second delta t minus 22 meters per second delta t minus 20 meters equals 0. So half of 2 is 1 meter per second squared delta t squared. 20 minus 22 will be negative 2 meters per second delta t minus 20 meters. So now there's my quadratic, right? T squared term, a t term, and a whole number term. So then we use the quadratic formula, and minus b, which will be a minus, right? So b is equal to minus 2 meters per second. A is equal to 1 meter per second squared, and c is equal to minus 20 meters. So delta t is equal to minus a minus, so 2 meters per second, plus or minus square root negative 2, because that's b, squared, minus 4a, which is 1 meter per second squared, c, which is negative 20. And it's all divided by 2a, 2 times 1. Okay, so simplifying, 2 meters per second plus or minus 2 squared is 4. Negative is positive. 4 times 20. So under the root you get 84 meters squared per second squared. And on the bottom 2 meters per second. Square root of 84 is, so this is 2 meters per second plus 9.165, etc., meters per second over 2 meters per second. Someone's at my door, squared. And the other option is 2 meters per second minus 9.165 meters per second over 2 meters per second squared. Obviously, this bottom one's going to be negative, so this is going to become 5.582 seconds. And now you're going to use this up here to find out how far did each travel. So 20 meters per second times our 5.5, what was it, 8? I'll just abbreviate it, plus 1/2, 2 meters per second squared, times the 5.58 seconds squared, divided by, I'm doing a video, that's why I didn't answer the door, equals, so when you do this you get, that's why I was saying shh when you came in. I knew it was your purse. I was just, You're welcome. 8, sorry about that interruption. That's what happens when you try to do a video while people are still at school. So 142.817 meters. And then you would do the same thing over here. It's just going to be 22 meters per second times 5.58. Of course, you keep all of the decimals in your calculator. And then when you do this, you get 122.817 meters. You look at the two of them, look at that. They are 20 meters in the difference. It means you did it right. Okay, and you don't have to use this negative time because obviously it's not going to be any good. Okay, so that's how you use the quadratic. I would say once you realize it's quadratic here, fill your numbers in and combine things and get it in the quadratic form. It'll make your life easier. Now, on the assignment, when you go to get your quadratic, it'll be through the time. So you'll set your two delta d's equal to each other. But the times won't be the same. So you might have like VI delta t plus 1/2 A delta t squared is equal to VAV delta t. But one will be like a T1. I think this is for number 6, and the other a T2. And so you can't solve this. You have to do like what we did in question number 6. You have to say, oh, T2 is equal to whatever it is in terms of T1. And then fill it in, and then your quadratic comes about, okay? So you don't get the quadratic quite the same way, but then once you get into a quadratic, you solve it the same way. All right? Very good. Sorry about that interruption in the middle.